In this tutorial, we're going to go ahead and solve an inequality. This inequality will be written just with one variable, not two variables. And we'll talk about kind of how to graph that inequality and put that inequality solution in interval notation. This skill belongs to the group Algebra. The skill itself is just solve a linear inequality in one variable, write the answer using interval notation, and graph the solution set. Prerequisites to do this: you got to be able to solve any type of linear equation handed to you, pretty much, because all those skills you're using to solve linear equations are the same skills you'll use to solve a linear inequality. You should also understand that multiplication division changes the inequality sign if you're multiplying or dividing by a negative. So maybe we should say by negative. You should also be able to interpret inequality notation. In other words, if somebody hands you something like x is greater than or equal to 3, you must be able to understand what that means. That x can be bigger than 3 and it can actually be equal to 3 as well. You should be able to graph an inequality on a number line. And finally, you should be able to use interval notation and its forms. For example, let's say 3 to infinity parentheses. You should know when to be able to use parentheses and when to use brackets. So let's use your prerequisite skills here, put them to work. Solving this inequality essentially just means treat it like it's an equality until or if we have to multiply or divide by a negative number. So if I'm going to pretend as though this is an equal sign, first thing I'm going to do is distribute this 5 to each of the objects inside that parenthesis, and I'm going to distribute this 3 to the objects inside the neighboring parenthesis as well. So I get 15 minus 5x, and I still have to, I know it's not supposed to be equal, so I'm going to copy the sign that they have there, and I'm distributing that 3x minus 9. And now I'll go ahead and gather up my x's. Now there's a couple ways you go about doing this. I always recommend whenever I teach a course, whether it's arithmetic, pre-algebra, beginning algebra, intermediate algebra, trig, calculus, any of the series, I always recommend when you isolate a variable, isolate it so that your variable is positive. In other words, isolate it so that I have a positive coefficient on my variable. In this case, I'm going to add 5x to both sides because I know that when I add 5x to both sides, well, the left-hand side remains as 15, but the right-hand side now has a positive 8x. And there's a strength to doing that. The strength is that I don't have to worry about that whole inequality flipping thing. Along the same lines, I'll add 9 to both sides. Now there's no rule when you add or subtract amongst both sides here. There's no rule about flipping signs, so we don't have to worry about flipping signs when we do this. Let's see, that'll be 24. Copy that sign, and I have 8x here. And now I'll go ahead and divide both sides by a positive 8. And that's important to state that I'm dividing by a positive number, because a positive number will not, multiplying or dividing by a positive number, that is, will not change that inequality sign. And so I get the following: 3, that symbol, x. Now to interpret what that symbol means. Inequality symbol always opens towards the larger number and always points to the smaller number. So if I'm looking at this inequality here, I know the smallest number it could be is 3, and the largest it could be is unknown. In other words, it keeps growing and growing and growing. What I'm going to do is draw out a number line, and I'll mark on there a few values. I'll mark 0. I'll mark 3, because remember, positive numbers, you go to the right. I'll mark out negative 10 down here. No reason to actually, to be honest with you, but I'm just doing that to show you something. Okay, so I know that when I start shading, I want all the values that I shade to be bigger than 3. So I'm going to start shading all these values larger than 3, or in other words, to the right of 3 on the number line. And because there's no end to it, I'll put a little arrow at the end. And now I have to ask myself, what happens at 3? Well, if you look at this inequality, this is telling me that x could be greater than or possibly even equal to 3. So x can actually be equal to 3. The way we notate that is using a bracket that opens in the direction of the shading. Now, I know some people have taught to use a closed circle. That's absolutely fine as well. So you might see some authors or some instructors that like to use this silly closed circle notation. There's the silliness about the closed circle notation is that it's only useful for the graph itself. What's nice about having the brace or the bracket notation is that I can easily see what my inequality is going to look like. So if I look at this bracket and the fact that it's shaded this way, I'm going to start writing my interval notation now. Remember, I've already graphed it, but I still have to write my answer in interval notation. And interval notation, you can use the graph to help you. I have a bracket at 3, and then it just keeps growing on and on forever to the right. That means on to infinity. Brackets mean that you include that point. And because we cannot touch infinity, infinity is just a concept, we must use a parenthesis. That means we exclude that point. And infinities always have parentheses on them because they're concepts, not real numbers. Another thing I should note about this interval notation is interval notation always goes from low number to high number, or on the number line, it goes from left to right. It's a common mistake I'll see that people will write an interval from like 5 to -5, which is absolutely wrong. You're going the wrong direction. Always should go from the lowest number to the highest number.